This is Mr. Beck Does Your Homework. This is AP Physics, homework 8.4, questions 1 and 2. Question 1 says, a gas is taken through the cyclic process described by the figure. Here's pressure in kilopascals and volume in cubic meters. From A to B to C and back to A again. Find the net energy transferred to the system by heat during one complete cycle. So what this is looking for is Q. Q is the amount of energy transferred by heat. And so that's in one cycle. Well, what I know is that in one cycle, I can say that delta U equals Q plus W. Actually, for any of these parts, I could say delta U is Q plus W, but I know that if I go once around the whole cycle, my delta U is going to be 0. So I can say that 0 equals Q plus W. So I can say that Q equals negative W. So that's what I can do to get to Q. If I knew the work done in one complete cycle, then I would know the Q done in one complete cycle. To figure out the work, well, the work is going to be the area in one complete cycle. It's the area enclosed by this triangle. As I go from A to B, this much work from here up to here, so pretty much this area from A to B and everything all the way down to the axis, that's the amount of work done by the gas, and it's negative work done by me. So if you think about that piston, what you're doing is you're letting it out. So you're pushing, but you're letting it out. So you have a force in that direction, but a distance in that direction. So you're doing negative work as this thing comes out. A lot of negative work. Then from C to A, well, B to C you have no work because the volume doesn't change. C to A, you're doing some positive work on the gas. So you're doing a little bit of positive work, but it's at a lower pressure, so it's going to be easier C to A than it is A to B. So this total area is going to represent some negative amount of work done. So if I know the area here, I'm going to be getting work out of the system, so it's doing more work on me than I'm doing on it. So it's letting it out difficult and pushing it back in easy. So I'm doing less work than I'm getting out of it. So this is a useful engine. I can use it to do work on the environment somewhere. So if I find the area there, that area, if this is a clockwise cycle, so if it's clockwise, that area is going to equal negative work. So what that's going to tell me is that if I negative a negative, I'm going to wind up with a positive Q as I go around the loop. So I just need the area of that triangle. So my area, of course, is going to be 1/2 my base times my height. So it's going to be 1/2. Let's see, my base from A to C. That looks like, for me, I'm going from 3 up to 9. So this is going to be 6 cubic meters. So my base is going to be 9. My height is in kilopascals. I'm going from 4 up to 4. Is that 14? I'd have to pull out my straight edge and see exactly where that's bringing me. And it looks like B is right to 13 for me. So be very careful where that is. So I'm going up to 13. So from 4 to 13, that is 9 for me. But that's kilopascals, so that's really 9,000. I'm going to take a little shortcut because if I did pascals, this would give me joules, but I want kilojoules, so I'm just going to leave that 9 there for me. So it's 1/2 of 9 times 9. That'll give me my area, and that's going to be some positive amount of work. And it says kilojoules. If I plug in kilopascals, I'm going to get kilojoules. If I plugged in pascals, I'd get joules. So that area is going to be the work, and that's going to be a negative number because it's negative work is the area. But I negative a negative and I get a positive, so that's going to be my Q. It's going to be a positive number for the amount of Q that I have to add going once around the circle. Part 2 says if the cycle is reversed, that is, the process follows the path A, C, B, A. So now I'm going counterclockwise. What is the net energy transferred by heat per cycle? In this case, I'm doing more work to it than it's doing to me. So I'm adding to it and it's getting rid of it, and I'm adding to it and it's getting rid of it, but it's getting rid of less than I add. So in order to reach the same temperature again, to get back to that same starting place and get to the same temperature, it's going to have to leak out energy instead of adding energy. So if it says net energy transferred by heat per cycle, well, if this is positive, then I know for this one, it's just going to be negative, that same answer that I had before. if I go around in the opposite direction. So anytime I'm clockwise around a cycle, it'll be negative work done to the gas, and I will be getting work done out of the system because the gas is what's doing the work. So anytime I'm clockwise, I'm also adding Q once around the circle, once around the cycle.